Okay, before viewing this video, I'd like you to have a look on the links part of Schoolbox. And in the links part of Schoolbox, I've got a link to a very good explanation of how this formula here for differentiation by first principles is developed. Far better than what I could do. Okay, and he explains it very clearly, and it's the best one about it to find. So I'm now going from the point where you're aware of this formula, and we're going to actually use it to differentiate using first principles. Okay, so remember gradient and the term f-x are interchangeable. Okay, so we're looking for a expression that will give us the gradient at a particular x coordinate. Now we've probably before differentiated x squared minus x quite simply. We should know by now from year 10 that it's just going to differentiate into 2x minus 1. Okay, so the good thing about these questions is we sort of know where we're heading. We know what the answer is going to be. Okay, so we're going to differentiate by first principles. Here's the example here. We're going to differentiate by first principles. F of x equals x squared minus x. And this is the formula we use when we differentiate by first principles. Limit as h approaches 0 of f of x plus h minus f of x over h, where h is not equal to 0. Alright, and this is the target here. Okay, that's what we're after. So let's have a look. The first thing we've got to do is find f of x plus h. Alright, so let's look at f of x then. F of x equals x squared minus x. Now f of x plus h is that expression, but instead of where x is, I'm putting x plus h. So I'll put them on top of each other here. Okay, so you can see, if you compare f of x with f of x plus h, wherever I had an x on the first line, okay, I've now got an x plus h there and there. Okay, so that's what f of x plus h is. Now that I know both of those, I can now apply the formula. Okay, from the previous slide, I've copied over the formula and I've copied over my f of x and my f of x plus h. Alright, let's put them in the formula. So f of x plus h is going to be x plus h squared minus x plus h. Okay, so I've done that bit. Minus f of x. Brackets are crucial here. Minus f of x, which is minus x squared minus x, all over h. Oops. All over h. And of course we've got limit, shouldn't forget that, as h approaches 0. Alrighty, let's expand the top. X plus h squared is x squared plus 2xh plus h squared. Okay, so let's just put a border around the things that we've covered. Okay, so we've done that. Next bit is minus x plus h. So we're going to minus both of those, minus x minus h. We've now dealt with that. Next one is minus x squared plus x. We've now dealt with that. Okay, we've got still limit as h approaches 0, and all of that hugeness is going to be over h. Now some big time cancelling can happen here, so let's have a look at that. Okay, so we've got x squared can cancel with the minus x squared, so they go. What else have we got? We've got minus x plus x, they can go. So what we're left with on the top is h squared plus 2xh minus h, and of course it's all over h, limit as h approaches 0. Okay, we're doing pretty well. We've got that far. to squeeze another bit onto this slide because we can now take out h as a common factor here. So we get h outside of h plus 2x minus 1. So I've taken h out of that expression there, okay, over h. Okay, and remember, I keep forgetting, I often do this, we've got limit as h approaches 0. Alright, so that's where we're at. We'll copy that over to the next slide, and we're nearly finished. Okay, what can happen now obviously is that the h's can cancel there and there. So it equals limit as h approaches 0 of h plus 2x minus 1. Now if we substitute h equals 0 into there, we get 2x minus 1, which is what we predicted. Said before that we started with x squared minus x, and we know if we differentiate that we get 2x minus 1. It's fairly predictable. So there we are. Differentiation by first principles. Let's do a quick recap. Over here is the formula. Okay, lots of ticks there. We already know f of x, and we have to find f of x plus h, and we do that by substituting x with x plus h. There it is there. Okay, then that goes on the top. F of x plus h minus f of x. Okay, multiply it out, cancel, and finally, last thing we do once we've cancelled everything that we can, we substitute h equals 0, and there we are. All good. Okay, now I'd like you to have a go at exercise 7b, numbers 11 and 12 on page 330. I've only done one example there, so I'm hoping that'll be enough. See how you go with it. That's all for now.